Okay, so we're on page 393 in your workbook, and adding and subtracting of rational expressions part 2. So things are going to start getting a lot more complicated, and it's really, really important that you now use those factoring skills that you've been working so hard on first, beforehand, because we really, really want them factored. It helps us to ensure that we can use the least common denominator and keep things as simple as possible. Okay, so let's take a look then. Oops. So very first one, so in all of these cases that we're looking at right now, they share a common factor. So it's no different than when we had 1/8 plus 1/6. Because they have a common factor of 2, that means that we can use a common denominator of 24 instead of just multiplying those two denominators outright to have a common denominator of 48. So keep in mind always what factors they might have already in common. So in part A, they have an x in common as well as a 5 in common. So our common denominator is going to be 10x. And so we're multiplying here, top and bottom, by 2. So then that gives us 6 minus 3, or simply 3 over 10x. That can't be simplified, but we have our non-permissible values or restrictions, so x cannot equal 0. For the second one, we want to factor. First, we can see these denominators have a common factor of x plus 1. So we've got 5 times x plus 1 and 2 times x plus 1, and numerators are still the same, so we have a common factor, which is x plus 1, so we only need one of those, x plus 1, but then we still need a common factor of 5 and 2, which is, of course, 10. So to get 10 times x plus 1, I need to multiply top and bottom here by 2, and top and bottom here by 5. So then we've got 4 times 2, or 8, plus 3 times 5, which is 15, or 23 over 10 times x plus 1. And again, there is no need to expand, distribute that denominator. We can leave that in factored form. And so our restriction x cannot equal -1, since the factor x plus 1 cannot equal 0. Looking at the last one, then, again, we have a common factor here in the second one of x, and so we'll factor out x, so leaving us with x plus 2. So here, then, our common denominator is going to be x squared, or x times x plus 2, which means we want to multiply the left one by x plus 2 over x plus 2, and on the right we just need to multiply by x and by x. So we've got 1 times x plus 2 minus 1 times x over our common denominator, and then x minus x is 0, and then plus 2, so we've got 2 over x squared times x plus 2, and our restrictions being x cannot equal 0 or -2. So moving on then, and at any time, I'm going through these fairly quickly because I don't want this to be a 1-hour video, but feel free to hit pause or rewind and replay that same thing. If you have further questions, just go and ask one of the other teachers, or you can send me an email as well. So in this particular case, we can see that there's a common factor of x minus 2. So that means that our denominator is going to have, we need an x plus 1, we need an x minus 2, and in order to make this a second 1, we need an x plus 4. So that means that in this particular case, to make it x plus 1, x minus 2, x plus 4, I need to multiply top and bottom by x plus 4. So now you can see, because it's getting more complicated, I'm going to write that all out so that I can communicate that clearly to you, and you likewise, when you're doing the work, can communicate that to me. And then here we're multiplying top and bottom by x plus 1 in order to get that common denominator. So 2 times x plus 1, and then we expand, so 5x plus 20 plus 2x plus 2, and all over our denominator, which is the 3 binomials. Yes, you need to write them all down every single time, and you do not need to expand them again. So combining like terms in the numerator, we have 7x plus 22, which is not factorable, and then our denominator, once again, x plus 1, x minus 2 times x plus 4. The denominator, those factors don't have to be in any particular order, but again, it's nice for when listing our restrictions that we do them in some ascending or descending order. So especially you'll see that we're going to have quite a few in some of these examples. So in this particular case, we have x cannot equal negative 4, negative 1, and positive 2. Okay. Moving on to the next example. So again, factor that denominator. So we have a difference of squares, p plus 1 times p minus 1 plus p plus 1. And so our common denominator is then going to be p plus 1 times p minus 1, and so this numerator stays the same. This numerator has to be multiplied by p minus 1, and so then we're looking at 4 plus 2p minus 2 all over p plus 1, p minus 1, and so we have 2 plus 2p, and conveniently I'm already noticing, and hopefully you are as well, that there's a common factor of 2 that we can take out, and so we're left with 1 plus p. Well, that's convenient because we have a p plus 1, which is essentially the same thing in the denominator. So just like when you're adding fractions and we recognize that we could take out a common factor at the end, simplify, we can do that as well here. So our simplified answer, because we can factor these out, is 2 over p minus 1. Our restrictions, remember, we still have to take into account the factors that have been canceled, so p cannot equal plus or minus 1, so negative 1 and positive 1. Okay, so, and you can see right here, he's saying exactly the same thing, so always check to see that our answers are in fully reduced form. So trinomial denominators, factor, 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 and factor. And you definitely want to try to simplify each fraction beforehand, if possible, before finding the least common denominator. So for example, going back to numbers, if you had 25 50ths plus 25 75ths, there's no way that you guys would find a common denominator between 50 and 75. I know that you can, but it would be a lot easier to simply add 1/2 plus 1/3 and find that common denominator of 6. So same thing for these ones then. If you can simplify first, definitely do that. Double check, triple check your factoring. Make sure you've got your numbers and your signs correct. Otherwise, it's going to change everything. So let's take a look at A. So we know we're going to have to factor that denominator. So we've got 2 over x plus 1 minus x minus 1, and this is x, and we've got 3 and 1, and it'll be negative 3 and plus 1. And so unfortunately we can't factor out the x minus 1 and x plus 1, but we do have an x plus 1 as a common factor. So our common denominator is x minus 3. So I need to multiply this top and bottom by x minus 3. So x plus 1 and x x minus 3, and so it's 2 times x minus 3, because we're multiplying again, top and bottom by x minus 3. Remember, you're subtracting this whole thing, so subtracting x minus 1, so I need to distribute that negative as well. So we've got 2x minus 3 minus x plus 1 all over x plus 1, x minus 3. And simplifying that then, we're looking at x minus 2 over x plus 1 and x minus 3, and nothing can be simplified there, so we'll just write out our restrictions. Our restrictions are based on the denominator only, so x cannot equal 3 or negative 1. Okay, let's take a look at the second one then. So again, factoring those denominators using your great factoring skills. So we've got y minus 2 and y minus 1 plus 3 over y plus 2 and y minus, nope, right? Y plus 2, y minus 1. Yes, that is right. So we have a common factor of y minus 1 and two unique factors of y minus 2 and y plus 2. So on the left, I need to multiply top and bottom by y plus 2. So we've got 1 times y plus 2. And on the right, I need to multiply by y minus 2. So 3 times y minus 2. So then we've got y plus 2 plus 3y minus 6 all over y minus 1 times y minus 2 times y plus 2, cleaning up the numerator, 4y minus 4 over y minus 1 times y minus 2 times y plus 2, extend that line, and then of course we can see that there's a common factor of 4, and knowing, thinking ahead, I know that I factor out the 4 and left with y minus 1, so that's going to be able to cancel with that y minus 1 that we have in the denominator. So we can factor out the y minus 1 to 1 over 1, and so we're simply left with 4 over y minus 2y plus 2. And again, no need to multiply that out. We do need, though, to write out the restrictions, even for the one that we've taken out. So we've got y cannot equal negative 2, positive 1, and positive 2. Okay, moving on. Oh, look at that. It's getting fun. So lots of factoring, and again, remember that because the kind of a hint right now, because you guys are just learning this, then there's probably going to be factors in common. If you're having troubles factoring anything, look at some of the other ones for clues. It's going to be very unlikely that you're going to have them all factoring and giving you totally unique factors. So here we go. X minus 2, x minus 1. Rather, why don't you hit pause and we'll factor it on our own, and then you can come back together once you're ready to go through the answer. Okay, so once you factored all 4 trinomials, you notice that these ones have a common factor of x minus 1. Don't scribble it out so much so that you can't see it, because remember, you need to write out your restrictions. And we also want to double check, triple check that we factor those correctly, because obviously that's otherwise going to change what our common denominator is. So a common denominator is now just x minus 4 and x plus 2, and so I need to multiply top and bottom here by x plus 2. Oops, that's right. So top and bottom by x plus 2, and there's that stinky negative, and top and bottom here need to be multiplied. I need to take that x plus 4 and multiply it by x minus 4. And up here, oh, conveniently, we're going to have two difference of squares. So we've got x minus 4 times x plus 2, and x plus 2x minus 2 is x squared minus 4, and minus, and it's going to be x squared minus 16, but if you're thinking ahead, because you're going to be distributing that subtraction, then it's x squared. Instead of minus 16, it will be plus 16. If you're not sure, then again, you can say you're subtracting the product of these. If you wanted to put another set of brackets, you may. So you're subtracting the product, you're subtracting x squared minus 16. So we're looking at then x squared minus x squared is nothing, and then negative 4, take away negative 16 or plus 16 is 12. So we've got 12 over x minus 4, x plus 2. And our restrictions, including all of those that we canceled out. So we've got negative 6, negative 2, positive 1, and positive 4. Okay, great. So let's take a look at example number 6. So show that that first expression can be reduced to the second. So I think that requires some factoring to start off with. So why don't you go ahead and factor that, hit pause, and then come back. Okay, so once we factored that, we can see, and some of you may have taken out a negative 1 already. I just factored it as is, but we can see that a plus 3 and 3 plus a is a common factor, so I only need one of those, and then I just need an a plus 4 and a 3 minus a, so that means top and bottom here need to be multiplied by 3 minus a, top and bottom here need to be multiplied by a plus 4. So I expand all of that, no negatives, no subtraction to worry about, so collect like terms, we're left with 7a plus 21, conveniently a common factor of 7, so a plus 3 is there, and then we're looking at a plus 3 and a plus 4 and 3 minus a, and so of course the a plus 3's can cancel out, and so then we're just left with 7 over a plus 4 and 3 minus a, but of course they're saying that it can be reduced to negative 7 over, and then that's because they factored out the negative 1 from the 3 minus a, making it a minus 3, and they've moved that negative to the numerator. So that's just 1 over 1 here, and then if I factor out a negative 1 from this, then we're essentially left with 7 over, and I'll put that as negative 1, and then we'll make that negative 3 plus a, and a plus 4. So this negative, we prefer, generally speaking, it's not incorrect to leave it in the denominator, but generally we prefer to have the negatives in the numerator, and then I'll rewrite the minus 3 plus a as a minus 3 and a plus 4. And so we've shown that they are equivalent. Excellent. You guys can do some practice now.